Hello, my name's Jack Bandy, and in this presentation I'll overview an audit study I worked on looking at how algorithmic curation impacts media exposure in Twitter timelines. A big reason I wanted to do this study is this prevailing narrative that social media algorithms are ruining the world. So whether it's on Netflix documentaries or Wall Street Journal's recent reporting, Katy Perry's tweets, or New York Times op-eds, there's a common tendency to blame social media algorithms for the problems in the world today. But we still don't have a great understanding of what these algorithms are actually doing. One of the larger studies we have on the topic is the 2015 paper by Facebook looking at how the newsfeed algorithm affects partisan echo chambers. There's a number of important limitations with this study, but I've highlighted one of the important takeaways, which is that the newsfeed algorithm really didn't have a big impact on the echo chamber effect. And this eventually led me to ask if the same would be true on Twitter with Twitter's new curation algorithm. Our study addresses two main research questions. The first is about how Twitter's timeline algorithm affects exposure diversity more generally, and the second is about how the timeline algorithm affects partisan exposure. Here's a brief overview of the methods we used to address these research questions. Before I do that, I want to mention that this is just a summary of the paper and there are a lot more details in the full study if you're interested. We used a sock puppet approach for this audit, and to set up the sock puppets we used this archetype selection pipeline. So we started with an initial pool of users, which was every account that followed US congresspeople on Twitter, and then we ran community detection on a group of left-leaning users and a group of right-leaning users. After that, we selected one archetypal user from each of the communities. Then we verified those users by making sure they were not bots and looking at the accounts they followed. The process resulted in 4 archetypal left-leaning users and 4 archetypal right-leaning users, and we set up one sock puppet for each of the archetypal users. Once the sock puppets were set up, it was time to collect data. We based our data collection schedule on some research from Pew looking at how people use Twitter on a day-to-day basis. We decided to collect data at 9 a.m. and 9 p.m. every day for 30 days, and each time we saved the first 50 tweets in the algorithmic timeline and the first 50 tweets in the chronological timeline. Here's an overview of the main results. At a high level, we found that 55% of tweets were suggested tweets that Twitter's algorithm adds to the timeline. We also found that the algorithmic timeline reduced exposure to external links from 51% in the chronological timeline to 18% in the algorithmic timeline. On average, 50% of external links led to news and information. We also found that algorithmic timelines significantly increased source diversity. In the median case, our sock puppets saw 662 unique accounts in the chronological timeline, but almost 1,200 in the algorithmic timeline. Algorithmic timelines also reduced exposure to more dominant accounts, as can be seen in the reduced exposure rate to the top 10 accounts and in the lower Gini coefficient. We also observed a slight partisan echo chamber effect. This can be seen in the increased exposure rate for niche partisan accounts and in the decreased exposure rate to bipartisan accounts. We didn't see as much of an echo chamber effect in terms of external domains, though one important thing to note is that we found baseline differences that were consistent with the Facebook study I mentioned earlier. Right-leaning puppets had a much higher rate of ideologically cross-cutting content in their baseline chronological timeline. Once again, there are a lot more details about our methods and the background and results all in the full paper, so check that out if you're interested. But to wrap up this presentation, I'll now go over a few takeaways. Some of our findings have important implications for journalism. Namely, the algorithmic timeline seems to reduce the reach of external links. This could be because Twitter is optimizing for engagement, or on-site time, or something similar. But whatever the reason, it makes it less likely that Twitter will increase page views and revenue for news websites. Another implication of our work is that algorithmic echo chambers are probably not as extreme as they seem in popular narratives. We also think that Twitter researchers may need to start accounting for suggested tweets when they study the platform. Future work might also look at which links do perform well on Twitter and whether our other findings generalize. To review these slides and see the full paper and more, you can go to jackbandy.com/publications. Thanks for watching.